Welcome, ladies and gentlemen. Today we're going to be talking about graphing square roots. Alright, you're going to need your notebook, and make sure you have a pen and or pencil and a calculator. Alright, let's get started. This is just a little review. You don't have to write this down, okay? We're just going to go through these general shapes. Remember, when we have something to the x squared, we're going to have a parabola. It's going to look something like this. We're talking about this right here. This is our absolute value symbols, so we're looking at a v. Right here, y equals mx plus b. We're looking at straight lines. And last, we work with these ones last. We're looking like a general shape of this sort. Okay, so that's just a little review. Today we're going to be graphing square roots. That's going to look a little bit different. You need to make sure you get this one down, please. This is the parent function of the square root. So I have f of x equals the square root of x. Now, if I think about this, I plug this in, I'm like, okay, let's start with -2. If I plug in -2 in my calculator, I'm going to get an error, so -2 doesn't work. But try -1 as well, plug in the square root of -1, it's going to come up as an error. So we can't start with those. We have to start with 0. Because if we plug in 0, the square root of 0 is just 0. So that's where we're going to start. Now if we plug in 1, the square root of 1 is just 1. And we can keep going. We plug in 2, get the square root of 2. We're going to get an approximation. We're going to say about 1.4. If we plug in 3 for x, we're going to get the square root of 3, and we're going to get approximately 1.7. Now, if we plug in 4, take the square root of 4, and this one's going to come out nice for us because 4 is a perfect square, and we're going to get 2. So after we make this fabulous table here, we're going to graph it. And your graph is going to look something like this. We're going to start at 0, 0. It's going to gradually go on in this direction. Now, very important, we're going to talk about domain and range. Domain and range, ladies and gentlemen, we're going to be looking right here. This is where we're going to steal our numbers for domain and range. Our domain is our x value. So we're talking about x such that x, if we look at this, 0, and it's only going up, so it's going to be greater than or equal to 0. Now our range is our y value, so if we look here we have a 0. So we're going to have y such that y is greater than or equal to 0 because our numbers are climbing here. This is our parent function. Now we're going to talk about a little bit about shifting. I would highly recommend you writing this down so you can go back and look at it, alright? Now the first 5 are just examples from the past. If we looked at this, x squared, which would be our parent function, we're not going to have any shifting. We're just going to be at 0, 0. Now, if we look at number 2, we have x squared minus 8. Well, that minus 8 makes us, this one right here makes us go down 8. If we look at the third one here, this negative makes it a reflection. So it's going to be flipped, okay? Keep going. If we look at this, if it's inside, we have this 6. This means we're going to go left 6. And now this fifth one here, we have a lot going on. This is going to determine how wide or skinny our graph is. This right here is going to tell us we're going to go right 4, and this right here is going to say we're going to go up 5. Now, if you didn't write any of this down, this right here is the most important. We need to make this written down in our notes. This is our general form for graphing a square root. So anytime we have a plus or minus something at the end outside of the square root, we're going to have a vertical shift. It's going to move us up or down. Now, what is inside our square root, so what's either added or subtracted to x, is going to be our horizontal shift. That's going to make us move to the left or to the right. Now, the a out in front, the number out in front of our square root, is our vertical stretch or compression. It's going to determine how big our graph is, if it's getting wider or skinnier. And our last one, that if there's a negative out in front, that's the reflection. Okay, it's going to be in front. It's going to reflect our graph. All right, we have 2 graphing examples and then we are done. So make sure you get both these graphing examples into your notes, please. So here we have our original problem. We're starting here. We have x and we have y. Now, I'm going to give you a little hint. When we're starting our graph to figure out where we need to start at, all we're going to do is take these numbers. So this is going to be 3, because it's always the opposite, and this one right here is going to be 4. So that's our starting point, is at 3, 4. That's where we're going to grab our numbers for starting. And then we're just going to go up from there. So for x value, I'm going to use 4, 5, 6, and 7. Now when we plug these in, if I take the square root of 4 minus 3 plus 4, I'm going to get the square root of 1 plus 4. Now I'm just going to type this into my calculator, and when I do that, I'm going to get 5. We'll do the same thing for 5. I'm going to take the square root of 5 minus 3 plus 4, which equals the square root of 2 plus 4. And I'm going to tack this into my calculator, and I'm going to get about 5.4. Continue on, we're going to do the same thing. Square root 6 minus 3 plus 4 equals the square root of 3 plus 4. Type that into your calculator. Square root of 3 plus 4. We're going to get approximately 5.7. And our last one here, we're going to take the square root of 7 minus 3 plus 4. We're going to get the square root of 4 plus 4. Well, we know the square root of 4 is 2. So 2 plus 4, and we're going to get 6 for that last one. Now what we do once we have our table completed is we're going to plug it in. So we come over to our graph. We're going to go 3, 4, 4, 5, 5, 5.4, 6, 5.7, and then 7 is at 6. Now, we can't go past this point. We're only going forever in one direction. So we can't have an arrow on this side. We're going to have a dot on this side, only going forever in one direction. All right, last but not least, we must do our domain and range. Domain and range, remember, ladies and gentlemen, comes from those 2 numbers right here. So my domain is my x values. So x such that x now is starting at 3 and it's only getting bigger, so it's going to be greater than or equal to 3. Now, if we come over here to our range, we're talking about our y value. So if we're looking up at our table, our y such that y, we're looking at this right here, we're using the 4, and then if we look at our numbers, they're only getting bigger, so it's going to be greater than or equal to 4. All right, that's all for that one. Last example, ladies and gentlemen, here we go. So first we have to decide where we're going to start. So we look at our graph. Now, this one says plus 2, so we have to do the opposite of that, okay? Opposite of plus 2 is negative 2. And then we're going to use whatever, exactly what's here, so we have negative 1. That's our starting point. Now, something I want us to be aware of, ladies and gentlemen, right now, we can't forget we're going to have a reflection. We have a negative out in front. So when we go through, we're going to climb, so we're going to have negative 1, 0, 1, 2. We're going to plug this in. Plug this in, we're going to have a negative square root. That's really important. Negative 1 plus 2 minus 1. That's going to equal negative square root of 1 minus 1. If you type that into your calculators, ladies and gentlemen, we're going to get a negative 2. Keep going here. We're going to plug in 0. So we have negative square root of 0 plus 2 minus 1 equals the negative square root of 2 minus 1, which is going to equal, if we type in our calculator, approximately negative 2.4. Keep going here. We have negative square root of 1 plus 2 minus 1 equals negative square root of 3 minus 1, which equals approximately negative 2.7. Move on to our last one. So we have the negative square root of 2 plus 2 minus 1 equals the negative square root of 4 minus 1. Now, here, we know this is 2, but it's going to be a negative 2 minus 1, which is negative 3. Now that we have our table completed, we're going to graph it. So I have -2, -1 right here. Then I have -1, -2, 0, -2.4, 1, -2.7, and 2, -3. Make sure this one is solid. We're not going past it. We're only going to go on forever in one direction. All right, there's our graph. Now we've done with our table, our graph. We have to finish with domain and range. So our domain and range, remember, ladies and gentlemen, is coming from these numbers right here. Okay, our domain is our x value, so we'll start with that. X, such that x. Now for this one, if we look at these, our numbers from -2, getting what, greater than or equal to -2. But if we look at our range, we're starting at -1. So we have y such that y. But if we look at our numbers are getting smaller. So it's going to be less than or equal to -1. All right, ladies and gentlemen, that is all I have for you today. And enjoy the rest of your day, and I will be seeing you later. Bye.